Welcome back, everybody. This is our second unit of Calculus 1. Derivative. So a derivative is, you could think about it as a tangent line, but that would be the derivative at one point. If we take the function, this is really the same function actually used for the limits unit. Excuse me. We can think about how is this function changing? And so, well, we could say that'd be easy at this point. The function isn't changing at all. The slope is 0. Same at this point. Slope is 0. But how can we describe this as a function? Well, it's quite easy actually. Let's take the function y equals x squared. F of x equals x squared. Y equals f of x. There's our little quadratic right there. And so, what if I took a point on this curve and I estimated the slope at that point? So if I took my point here, I took my point here, I drew a line through there. That's what we call a secant line. And so, all that really is, well, we have our 2 points, call this one x and this one a. Because I'll give you a little insight here, we plan on changing x. And so this point here would be f of x, and this point here would be f of a. For lack of space, I'm just not going to write f of x there, but we all know that's f of x. Because it goes across. Anyways, what's the slope of this line? Well, the slope, we'll represent it by m, is the rise over the run. So the rise is f of a minus f of x over the run, which is just a minus x. So that's an estimation of what our slope is, but how could we get the exact slope at the point A? Good question. Very good question. Let's think. Well, we could bring f of x, or x, we could bring x closer to A. That would make it a bit closer, but we'd still have a secant line. And I mean, well, it would be perfect if x equaled a. Think about that for a second. If x equaled a, we would have a minus a on the bottom. We'd have 0. How do we evaluate a function at a value that doesn't exactly exist? That's a limit. So the exact slope is equal to the limit as x approaches a of f of a minus f of x over a minus x. Check that out. Limits have haunted us again. So, let's call a 2. Let's say a equals 2. What's the slope at 2? Well, f of x equals x squared. So f of a is just a squared. A equals 2, so that equals 4. 4 is 2 squared. So we've got the limit as x approaches 2, right? Limit as x approaches 2 for 4 minus f of x is x squared over a is 2 minus x. So this is our slope at 2. And this is equal to, well, this is a difference of squares, so we've got the limit as x approaches 2 for 2 minus x, 2 plus x over 2 minus x, and that's just the limit as x approaches 2 for 2 plus x, and that just gives us 4. So what's that tell us? The slope of x squared at the point 2 is 4. Cool. Very, very cool. Now we could have did this without numbers, and we could have found the slope function for x squared. Now, you guys can try that on your own. I'll tell you. I got a little magic trick in my head. I think the slope function is 2x. Now we'll find out why I actually said that in the next video, but for now, I'll just show you guys that function we can call f prime of x, or we could call it dy dx. So it's the derivative of y with respect to x. So, I mean, that's all it really is, 2 derivatives. So, thanks for listening.